Hello gentlemen, today inshallah I'll start to talk about the first session in our semester about the physics. We have to define the meaning of physics. حضراتكم you took it before, science, general science. The general science contain physics, chemistry and biology. But now we are talking about physics. Let's talk about physics يا شباب. Physics, a branch of science which studies physical and natural phenomena around us. أي physical phenomena, any natural phenomena around us related to physics. Like what يا شباب? If we talked about the formation of rainbow, حضراتكم rainbow after the rain, you can see 7 spectrum colors. This related to physics. حضراتكم you'll know that after that we have reflection of light and refraction of light. We have droplets in water, of droplets of water vapor in the air. When the white light of the sun start to fall through these droplets, it will decompose to form 7 spectrum colors. كل ده related to light refraction وده يعتبر physics. Also we have light reflection. If we have light, when the light fall on the mirror and returns back, this is the meaning of light reflection. All of these phenomena according to physics are related بمين يا شباب؟ بالphysics. So first let's define the meaning of physics. Physics, branch of science which studies physical and natural phenomena around us. As I said, like formation of the rainbow, light reflection and light refraction. Okay, let's talk about the physical quantity يا شباب. Actually physical quantity, any quantity that can be measured, I can name it as physical quantity. يعني like what? If you talked about the distance, distance تعتبر physical quantity. ليه? Because it has unit which is meter or centimeter or kilometer or millimeter. So distance is physical quantity. Also, if you talked about the volume, we have 3 dimensions, so it will be meter cube, centimeter cube. So we have unit, so this will be physical quantity. Okay, so this is the second thing about the physical quantity, any quantity that can be measured. And as we said before, like distance and volume and density, all of them examples for physical quantities. Okay. Actually, here we have very important topic about the difference between types of units. Actually, we have 2 types of units. We have base or fundamental units, and we have derived units. Actually, the base units related to SI unit, System International Unit. عندي يا شباب 7 base units. You have to take care about all of them. عندي يا شباب المتر, and this will be the unit for length, kilogram. This will be the unit for mass. Second, this will be the unit for time, ampere, which is the unit for the electric current, Kelvin, unit for the temperature. طبعا we have many units for the temperature. We have many units like Kelvin, Celsius, Fahrenheit. But if we talked about what is the base unit for the temperature, it will be Kelvin. Actually, also the length. We have many units for length, meter, centimeter, millimeter. But what is the base unit for length? Meter. We have many units for mass, kilogram, gram, ton, but which is the base unit for mass will be kilogram. Okay. Also we have mole, which is the unit for the amount of the substance. Also the candela, CD, which is the unit for the luminous intensity. So we have from 1 to 7, we have 7 base or fundamental units. Okay. The second type of unit, which is derived units. Actually, these derived units came from base unit. Like what? Let me give you an example. If we talked about the, for example, here we have the force, which is Newton. يعني force, its unit is Newton. Actually, the Newton from derived units, because it's not found in the 7 base units. And let me tell you another reason for that. Force equal F equal M times A, mass times acceleration. So what is the unit for mass? Actually, it will be kilogram. What is the unit for the acceleration? Meter per second square. So this means that 1 Newton equal 1 kilogram dot meter per second square. So Newton from derived units. Why? Because it came from base units. Kilogram, base unit for mass. Meter, base unit for length. Second, base unit for time. So Newton from derived units, because it came from base units, as I said. Okay. So this is the derived units. Also, you have many examples for the derived unit. Let me give you another example for the derived unit, ya shabab. We have frequency. Frequency equal number of complete vibrations divided by time. Frequency, its unit is hertz. يعني الفrequency, its unit is hertz. HZ. Okay? Actually, hertz, not from base units. Hertz from derived units. Why? Because it came from base unit. Like what I'll tell you now. Actually, frequency equal 1 over periodic time. And what about the unit for the periodic time? Second. So equal 1 over second. So let me write here. So this means that here 1 hertz equal 1 over second. So I can write second negative 1. So 1 hertz equal 1 second to the power of negative 1. So as you see, hertz, which is the derived unit, came from second negative 1, which is the base unit. So second, an example for derived units. Actually, we have many examples for the derived units, like what? Like here we have hertz, as I said, hertz. Okay, and also we have Newton and Joule, watt, Pascal, Coulomb, volt, ohm, and Tesla. So these are the units, and these are the quantities of these units. Okay. After that, let's talk about the standard form or scientific notation. Actually, if you have this number as you see in front of you, we have many zeros. So it's not better to write it as it is. We have to change it into scientific notation or standard form. How can you took it in math? For example, I have 4.4 and we have many zeros. So if I want to change it into standard form or scientific notation, I can write 4 point. I'll put the decimal after the first digit. And after that, I'll start to count the numbers after the decimal. So how many numbers we have? 3, 3, 3, 3. So we have 12 numbers. So 4.4 times 10 to the power of 12. So here, this is the standard form for this number. Also this number, 7, 3, and we have many zeros. I can change it into standard form or scientific notation. How can I write 7 point? This is the decimal, 0.3. After the decimal, how many digits we have? 3, 3, 3, 3. So we have 12 digits. So times 10 to the power of 12. And this is meter. And also this is meter. So now we changed the number that have many digits or zeros into standard form or scientific notation. So this is, as I said, and also this, the second example. Unit prefixes. Actually, this is very important topic. First, you know the base unit for length is meter. Actually, we have multiples of meter and we have fractions of meter. How can? For example, if I want to measure the distance between two cities, so it's not logic to measure the distance by centimeter or millimeter or meter. I can use it, or I can use kilometer to measure the distance. So I have to use unit greater than the base unit which is meter. I have to use kilometer, for example, because kilometer, it's multiple for the meter, right? Another example, if I draw a line in your notebook, how can I measure this line? By any unit. Can I measure it by kilometer? Yes, you can, but it's not logic. You can use centimeter or millimeter. So I have to use fractions of this unit. So I can use multiples of the unit or fractions for the base unit. So here we have prefixes, and actually you can convert from one prefix to the other. just by multiplying by specific factor as you see in front of you in the table. Actually here يا شباب, if we start from deca till it reach to tera, so these are the multiples of the unit. يعني here we have tera, giga, mega, kilo, hecto, deca. All of them greater than the unit, يعني multiples of the unit. But if we start from deci to pico, so here we have fractions of the unit. So according to the situation, you have to mention which unit that you will use. And it's too easy to convert from one unit to the other unit, as I said, just by multiplying by specific factor in front of you. So here, for example, if we want to change from terameter, for example, to meter, what should I do? I have to multiply by 10 to the power of 12. From gigameter to meter, multiply 10 to the power of 9. From megameter to meter, multiply 10 to the power of 6. From kilometer to meter, multiply 10 to the power of 3, and so on. But if I want to convert, يعني for example, if I want to convert from meter to terameter, multiply 10 to the power of negative 12. Just get the other sign for the power. Opposite the sign for the power, or divided by 10 to the power of 12, but it's better to multiply. Just convert the sign of the power. Another example, from kilometer to meter, multiply 10 to the power of 3. From meter to kilometer, multiply 10 to the power of negative 3. So just convert or opposite the sign of the power. Okay, so these are the prefixes, as I said. Significant figures, very important to know the significant figures. I'm sure that you took it in math, but let's make quick revision about the significant figures. Actually, we have يا شباب يعني important significant figure rules. You have to know all of them to know how many significant figures. Why? Because in physics, in the mark scheme, he will ask you to get the answer, but in at least 2 or 3 significant figures. But it's better to write the answer in 2 significant figures. So you have to know what about the significant figures? How can I count the significant figures? So let's start. Actually, here the first rule. Here he said non-zero digits are always significant. يعني for example, if I have 3, 2, 5, 6, how many significant figures? There is no zero here. So just count the digits. 1, 2, 3, 4. So we have 4 SF. 4 significant figures. طيب. Zeros between non-zero digits are always significant. Give me an example. If we have 5, 0, 0, 0, 3. How many significant figures? Here we have zeros between non-zero digits. So you have to count all of them. So 1, 2, 3, 4, 5. So we have 5 SF. 5 significant figures. Here we have, you have to know the difference between 3 and 4, leading zeros and trailing zeros. Actually, leading zeros, the zeros on the left, trailing zeros on the right. For example, any zeros in the left, you cannot count them. You cannot count them. Any zeros on the left, we can name it as leading zeros. For example, if I have 0, 0, 5. So here, how many significant figures? I said leading zeros on the left, you cannot count it as significant figure. So we have only 1 SF. 1 SF. 1 significant figures. Right? Even if the number contain decimal or not contain decimal. يعني for example, 005, it will be 1 significant figure. Let me give you an example, another example. If we have 0.0003, how many significant figures? Here we have decimal, no problem. Also, you'll not count the zeros on the left, even there is a decimal or not. So here also we have 1 SF, 1 significant figures. Let's go to number 4, trailing zeros. zeros on the right. Zeros on the right. Actually, you can count the zeros on the right only if we have decimal only. For example, if we have 0 or 5.000, how many significant figures? Here we have zeros on the right, but we have decimal. So actually here you have to count the zeros on the right because we have decimal. So we have 1, 2, 3, 4. So we have 4 SF, 4 significant figures. Okay, but if there is no decimal and we have zeros on the right, you will not count them. يعني for example, you have 6 and you have 3, 4, 0, 0, 0. We have here trailing zeros, but there is no decimal, so you'll not count them. So only we have 1, 2, 3. So we have 3 SF, 3 significant figures. And here we have many examples for that. For example, let's talk about the last one. 0.0006100. Actually, we said zeros on the left, leading zeros are not counted, not significant figures. So cancel all of them. And zeros on the right, we can count them because we have decimal here. So we have 1, 2, 3, 4. So we have 4 significant figures. It's too easy, ya shabab. And also here, 0.0000476. This number, the zeros on the left, you will not count them because leading zeros are never significant figures. But let's go to the other digits. We have 1, 2, 3. So we have 3 significant figures. Also, we have 4.76000. This number. Here we have trailing zeros, but we have decimal. So you have to count the 0. So we have 1, 2, 3, 4, 5, 6. So we have 6 significant figures. Actually, here we have worked example. Let's mention how many significant figures in each number. Actually, here we have 82. There is no 0. So all of them, you can count them. We have 2 SF. Okay, 27.3, 3 significant figures. 0.0008, zeros on the left. You cannot count them. Only we have 1 significant figures. The zeros between non-zeros are counted. So 1, 2, 3, 4, 5, 6, 6 significant figures. Here you have 0 on the right, but you have decimal counted. So 1, 2, 3, 4, 5, 6. We have 6 significant figures. Here you have 0, 0, 0. You will not count it because there is no decimal. So only we have 1, 2, 3, 4, 5, 6. So we have 6 SF. 6 SF. 6 significant figures. Zeros on the left, you will not count it. So we have 1, 2, 3, 4. Here 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 significant figures. 1, 2, 3, 4, 5, 5 significant figures. Here we have decimal and we have trailing zeros, so you have to count it. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 significant figures. Okay. After that, this is the objectives of Cambridge about the updated syllabus. You have to take care about the updated syllabus, the core and supplement. Actually, let's start talking about the measuring length. You can measure the length by many instruments, by many tools. How can? For example, I can use ruler to measure the length. Here we have the ruler up to 30 centimeter and its accuracy 0.1 centimeter. Its resolution is 0.1 centimeter. What does it mean? Accuracy means the least scale. Ruler, the ruler, 3 centimeter ruler, it starts from 1 milli. So its accuracy will be 1 milli or 0.1 centi. Okay. After that, we have meter rule up to 1 meter. Accuracy 0.1 centimeter. And also measuring tape. Okay, the distance is more than 1 meter. If I want to measure large distance, it's يعني I cannot use the ruler and I cannot use the meter rule. I have to use measuring tape. And its distance, يعني if the distance more than 1 meter and its accuracy will be greater than the ruler and meter, it will be 1 centimeter. So this is the ruler as you see in front of you. But what happens if we have greater distance or large distance? It's too difficult to use the meter or to measure, to use the ruler or the measuring tape. Actually, I can use trundle wheel. So here I can use trundle wheel, this one, to measure larger distance. Larger distance. Look to this example. The diagram shows 4 identical ball bearings placed between two blocks on a steel roller, as you see. Calculate the diameter of one ball bearings. Actually, we'll start from here. Let's draw the line, vertical line, and end with this line. So he asked you to calculate the diameter of just one ball bearing. Actually, we started from 4 centimeter and end with 12 centimeter. So 12 minus 4 equal 8 centimeter. So this will be the distance from here to here, as you see, from this point to this point, from the start till the end. Then divide this number by how many balls you have. 1, 2, 3, 4. So 8 divided by 4 equal 2 centimeter. So the diameter for one ball equal 2 centimeter. So this will be the answer.